format. So if we take a look at this, you should have something like this pop up, and then basically it'll guide you through each of the lessons. And then what I did here is just kind of start with what are computer networks, what you're going to learn, a nice little infographic that hopefully puts everything together for you that I created with Notebook LM. And basically it guides you through how to connect devices. And then here also with Notebook LM, I created this video overview for you of the entire chapter. So I just added it here. As you'll see, key terms are very important in this chapter. So and most chapters. So I've always have some flashcards here for you for these key terms. And like I said, you should be able to copy paste these. So if you just highlight it, it should be able to hit Control C or Command C and copy it into your concept notebooks. And so here we're going to go through quite a few of the computer networks, like personal area, local area, wide area networks, and comparing each of these. And so make sure you click through these to kind of go through all of them. And then basically you just move on into the next, like your check your understanding. This is a very good idea of what you'll see on your exam. You can use your concept notebooks on your exam, but that's the only item you can use. So I would recommend that. So I have a question in the chat here for the reading assignments on Connect. How are those graded? I did some yesterday, but I couldn't find anywhere to answer questions or stuff like that. So I wasn't sure if I just had to read or do something else. No, the reading assignments, you just have to read. Yeah, there is no grade associated with that. I just put those in your here, in the lesson, so that way you do read it. So yeah, so that's and that I have to add it here because since we don't really have a textbook, that's the way that you read the reading assignment. So your reading assignments are not graded at all. Your ALA, your alternative learning assignments are graded. Your quizzes are graded. And anything in the class materials is not graded. So your reading is not part of your final grade. Good question. Awesome. So back to these, check your understandings. This should hopefully get you to, give you a good idea of what to expect on the test. And then here we go into how the internet works, the architecture, the protocols, and the data flows. So read through this, and it's just a summation of what's in your chapter. And then the backbone of the internet, the key components of internet data flows. You'll see routers, packets, servers, again, switches. Make sure you know all of these terms for your exam, and you'll see them here as well. So just another, kind of a double, like more of a repetitive nature, but hopefully to stick it in your head, all of those terms. And then we have IP addresses, the structure, whether they're static or dynamic, which we'll talk about today, the role in communication. And then here is a process on data transmission, right? You initiate communication, and then the data is packet, and then you address the data, it gets routed to where it's supposed to go, it reassembles, and then you have hopefully a delivery confirmation. So that's just a nice process of how we transmit data from one place to another. Then we have different layers. These are very important for your exam as well. So make sure you have those in your concept notebooks, your network access layer, your internet layer, your transport layer, and your application layer. And then we have another check your understanding. And so hopefully these terms will help you to prepare or kind of guide your concepts, and what you need to work on. Then we have the internet as a platform of communication, the web or GIS. And then you'll see here, we have internet-based communications like World Wide Web, email, right? Instant messaging, file transfer protocols, and EFTs are electronic funds transfer. And then understanding the components of the web, HTTP, the URL, HTML, and hyperlinks. And then again, key terms, I can't stress enough all of these key terms. So make sure you include those in your concept notebooks. And then we have Web 2.0 and 3.0. And so know the difference between those. And it's always changing, right? The web, and now we have AI, so that's even changing greater. Exploring your graphic information systems, what it is, how it works, the business applications of these geographic information systems and the internet. And so again, we have more check your understanding. And then we move on to mobile connectivity and cloud computing and connecting it all. and cell phone communications. And again, another process here where you're just, we're probably so used to this by now, right? Where we start a call, transmit to the cell tower, and then it moves from switching stations. And then we have some analog digital conversations and hopefully reception and response. We all know, like, are you there? Can you hear me? We've all seen that. So, and then here is what is the Internet of Things and how it works and how it is utilized in businesses and the challenges and opportunities. We have 5G connectivity now with our cell services, so hopefully that gives us faster speed, greater capacity, and lower latency. And then we have more information on cloud computing and cloud service providers, Amazon Web Services, Google Cloud, Salesforce, Camerata. And so we have all of those. And then we have some cloud security policies, data protection and encryption, I think is one of the most important, vendor agreements and compliance, and virtual private networks. We at IUP have a virtual private network, and most universities do. So then we have another check your understanding. And then we move on to web services, blockchain, and some collaboration of technologies. And so that's what we'll cover today, which is a content delivery network, how we can optimize web performance, the different web service models that we have, which we'll talk about, and blockchain, what it is. Make sure you have this in your definitions as well, how it works, the business applications, and always the advantages and the challenges that we are associated with. A lot of terms here, so make sure you know hash and mining, blockchain, cryptocurrencies. We see that quite a bit in the news, and some popular cryptocurrencies. These are usually the top three. So, and we have enhancing business productivity, like collaboration software benefits, some of the popular tools that we use. And then we have another check your understanding. So you want to go through all of this, and then I will add after today, I will add, like I have in the previous lessons, the lecture videos from our PowerPoint slides, so we have everything all in one place. But I would recommend that you use these lessons as a great study tool. And so we'll cover the next one. We'll cover Module 13, the business computer applications, on Thursday. So let me stop sharing a minute. Any questions so far? So all I did was go right here into our PowerPoint presentation to download this guy, and then I went right here in the concept notebook to download that guy as well. And then if you look here, this is your concept notebook. Let's make it a little bit bigger so you can see. So it gives you a lot of information. So right here in the notes is where I recommend that you type in all of your notes. So as we talk about networks, if this isn't enough information, add in here any additional information that you think you'll need for the exam. So that is my recommendation, because you see here, it gives you a little bit of information. It gives you the definition. So if you need a little bit more, that's what you should be adding to each of these note areas, because you are able to use this for your exam. And so if you don't know, what these are and these support functions don't help you, then add anything else that you see in the lessons or you see from the quizzes that you take. Anything on the quiz that you add to your notes, you can't add it in a question format. So you have to add it in a sentence format. So this is like a study guide for you. So if you miss any questions on the quiz, I would recommend you put notes in here to help you, because that's a good indicator of what you're going to see on the test as well. This is the concept notebook that we are in today. Awesome, great questions. So that is what I recommend. So if you look at your concept notebook, it gives you a lot of details, and then I would type in these notes anything else that you need for each of the items. It'll give you like just basic information about each of the items, but then I would recommend that you add more. And like I said, if you're taking the quizzes, make sure that with the quizzes, anything that you miss, you're adding here as well. So I would have this open and have your PowerPoint open as we go through it, and maybe take from the PowerPoint any information that you need to add to your concept notebook. Awesome. All right, so let me set this up. Any other questions before we get started? Again, great questions in the chat. So now we know where to find the concept notebooks, how to use the concept notebooks, and how to use the PowerPoints, hopefully, and the lessons. That's what we've covered thus far. Just give everybody a minute to see if there's any questions in the chat or otherwise. So I think we've covered everything. Awesome. If not, just keep popping them in the chat and I will go ahead and make sure that I answer those. Okie dokie. Let's put blue in here. So today we are going to talk about computer networks and the internet. So first and foremost, a network is a group of two or more devices, computers, something that is connected together to allow for the exchange of information and to share resources. So most computer networks are linked together and supported by the internet. And different computer networks support different software and different software applications. So you could have access to the World Wide Web, you could have access to digital video, audio, storage, application servers, email servers, etc. So a network is just basically a compilation of devices or computers. So let's start with an overview of our computer networks and the internet. So a network, like we said, is just a group of two or more devices or computers that are connected together. And the key purpose, I keep doing that. And the key purpose is to exchange information or to share resources. So you might have, like we do at IUP, we have a printer, let's say at the beginning of each office, and then all of us connect to that printer to print like our tests, if we still give tests on pen and paper. And then a network size, you could have small, you could have large networks, you could have the internet, which is the largest. So make a note of this. The internet is the world's largest network. So that's an important key piece that you'll see again. So the internet is the world's largest network. And the whole purpose why we do networks is because it allows us to share these resources. Keep in mind that businesses have scarce resources. Even if you are Apple or Microsoft or Alphabet, you still have scarce resources like cash. So by allowing the sharing of these resources through a network or through the internet, you don't have to spend as much on these resources. So then these are very important aspects, and make sure you have these in your notes. All of these computer networks, there are four basic ones. We have a personal area network, we have a local area network, we have a wide area network, and then we have internets. So make a note of all of these. So your personal area networks, usually laptops, tablets, smartphones, maybe within your home. Then a local area network is you might have it in an office or a store. So that would be the entire office location. Then you have a wide area network, which is you might have these in two geographic locations. So as a CFO, for example, we had a wide area network because we had different networks in certain distribution areas of the country to help, all of our salespeople connect to the data. Then we have internets, which connect all of these. So we have local area networks, wide area networks, and any other internets. They all work together, and it's basically a network of networks. And like we said, internets are the world's largest networks. Okay. So let's dig deeper into local area networks. Here we're trying to connect devices, but we have it within a limited geographic range. I don't know why it keeps doing that. Jesus. Within a limited geographic range. Let me see something here. There we go. Let me see if it'll let me. No. Hold on one second. Sorry about that. Discard. Let me stop sharing. I tried to put, and then I lose a monitor. Darn it. Darn it, darn it. Hang on one second. Let me redo this for us. Sorry about that. Okie dokie. All right. So we talked about these networks. And then let's dig a little bit deeper into our local area network. So here we're using a bunch of devices within a limited geographic range. usually not more than a mile or a half a mile. And there, everything is pretty much located within some organization. And usually that's our local area network. So you can connect through a variety of ways, either wired. So at IUP, we do have most of our computers, in the office are directly wired, but then you students might connect wirelessly, right, through the Wi-Fi that we have at IUP, and then or you might connect to your peripheral devices through Bluetooth. And then take a note of this, the IEEE. So that is the Institute for Electrical and Electronics Engineers. Oops, what happened here? So the Institute for Electrical and Electronics Engineer, they actually establish and publish protocols, which are just like rules and guidelines, and how to support these local area networks. And so this groups of standard, make a note of this, is IEEE 802. So you might see that on your exam. So IEEE 802 gives us the Institute for Electrical and Electronics Engineers, and it gives us the rules and regulations on how to pretty much work with local area networks. Now we have wide area networks, or WAN. Same thing, we can put in a bunch of devices, but this time we might have it over 2 or more geographic locations. And the whole purpose here is to facilitate communications and share information, hopefully across devices, maybe across cities, maybe across countries. So I would say most of the wide area networks that I've been involved with is usually around the United States, but you might have, I had a company that I worked for that also had, establishments in Australia, so you could have those across different geographic areas. And this one, we're usually trying to use this to facilitate data and information exchange across multiple locations. Like I said, you might want to share with your sales team, and maybe you might want to make sure that they have enough data in order to provide those sales and turn those into revenue. So usually some vendors, Cisco Systems and VMware, are like the top vendors that provide wide area networks. And this is what it looks like, right? So here you have local and wide area networks. Here is your internet, right? The largest network of all. Then you have all of your peripherals, whether it's a desktop, a laptop, a phone, a printer, everything connects through it. And then you have devices like a router or a switch that provide all of the like centralization and kind of the logistics for your local area networks and your wide area networks. So how do you connect everything? Well, first you need an ISP, an internet service provider. And what an internet service provider does is it gives you the internet protocol, your IP address. It gives you a gateway to the resources of the internet. And basically it pays for access to the internet. So they charge a fee. So we all pay for internet, and voila, then you get access to everything out there and you don't have to leave your home to learn anything. So how do we connect to the internet? Well, obviously you need to be connected to a network, then you can connect to the internet. You might also want to be connected to your local area networks. That could be via fiber optic or cables or a digital subscriber line or coaxial, or you could do it wirelessly sometimes through local area networks. So the idea is, this is all the mechanics behind how we connect to the internet. Oops. So then we have packets that move through the internet. So here we have keeps doing this, sorry. A package assembly, right? So a package is just something that's ready for shipment. And it has a mind of its own. It's like keeps going crazy over here. There we go. See if that works. So a package is ready for shipment, and basically then you have a putting name package, which is the name of the business, right? In this case, Amazon. Amazon, one of my favorites. Like that's the way I shop. Then you have a Google search for the phone number. You could look at the IP address. Then you have the IP addresses added to the package. Then you have the TCP right here, which is your transmission control protocol. And that makes sure that you get the package. And then you have the message is sent through your internet service provider. And then you can hop or move to another network. So that's how the internet works in a nutshell. So all of this is happening behind the scenes. Make sure you know what an IP address is. It's basically just a number that's assigned to all devices, whether it's a modem or router, and it identifies that device and it allows the IP address allows you to communicate with each other over that network. And so when you think of an IP address, it's kind of like your home address, right? In order for you to get something, you need to make sure that you have someone's address. Well, in order for it to get to that computer, you need to make sure that you have an IP address. Without that, you really can't get any information. So IP addresses can be assigned permanently. So if it is assigned permanently, they're known as static. So like your email server may be like, a business address or from a pool of available IP addresses that is given by your internet service provider. When you are at IUP, we usually have, if you're connecting wireless, you connect via a pool of IP addresses. And then based on those IP addresses, we can tell what building you're in or, what location you have. So in Everly, we have a whole set of IP addresses. So the format is usually 4 decimal notations. So this is, you'll see something to this effect. And basically there are 4 billion IP addresses, which is a lot less than the 7 billion people on Earth, but it's also being adapted to change the format. So instead of the 4 decimal, we are moving to the 6 decimal. And so you'll see something like this. So it's getting bigger and bigger because we have so many different types of devices that are connecting at all times. Okay. So then we have TCP/IP, Transmission Control Protocol, Internet Protocol. So make a note of that. TCP/IP is a suite of communication protocols that connect devices. So you can either have network access, which will give you the physical parts of sending and receiving data. You have the internet, which is the packets of information through the network. Then we transform that. So we kind of divide the data into segments and then basically put those packets, acknowledge that those packets have been received. And then we have applications, which can be messaging or email. And this is just different applications that we use throughout the network. So when computers and other devices communicate with one another, they use this TCP/IP. And it's just like we said, a system of rules. It's like listed and it's step by step what each computer is connected to the internet and what they're using. And in order to connect to the internet, other computers on the network, they need to have a network interface card. And so basically, or some type of cable or wireless technology that allows you to connect to the internet. So services to users. So these devices that we connect to the internet, right? We have a lot of different resources, and the main purpose is hopefully we are increasing communication and efficiencies. Like I said, in business, time is money, right? So the more efficient and effective we are, the better. Hopefully the bottom line is. And so certain resources that the internet provides us is the World Wide Web, right? We can chat and do instant messaging. A lot of companies are using like Monday.com or Salesforce. We have FTP, file transfer protocols, which is how we're communicating to one another and hopefully transferring data. Email, right, is the number one way I think that I communicate. And then EFT, we talked about electronic funds transfer. Very few, I think, companies nowadays actually write checks. Most of it is done through wire transfers or EFTs. So the World Wide Web and the GIS systems, the Geographic Information Systems. So the World Wide Web, www, right? It's just a bunch of web pages that we're able to access from anything, right? And it has different components. So we have HTTP, which is a protocol for transmission of hypermedia documents, HTML, right? So those are hypertext markup language, as you see here. So this hypertext markup language is just what we format to make our web pages pretty. And then the URL, the Uniform Resource Locators, that's like the actual website address. So in our case, www.iup.edu. That's our URL. And Web 2.0. So Web 2.0 refers to the second generation of internet, and this gave us more interactivity. It gave us some dynamic content that it was responsive with maybe some user input. It allowed us to classify information, so that gave us the folks on autonomy. It gave us user participation where we can go from, site to site. Maybe we could do reviews, we could do some evaluations. And here's the important part, software as a service, SaaS. So when we had Web 2.0, we kind of got this new application programming interface, APIs. And this is like the interface between the software program, and it allowed for more automated use. And so SaaSes are becoming more and more integral to businesses nowadays. So geographic information systems, or GIS, here we're trying to find out the location, right? So we try to find a target area. We route information. So the user, right, they have their destination, and then the geographic information system like helps in providing maybe directions, alerts, gives us maps or quantity maps where we know what things are happening. So this is just a more geographic way of getting data. Then we have Web 3.0, and now this is the next evolution, right? So now we have the Internet of Things. And this is where the controls and many of the processes that we have today is where everything lives. So the Internet of Things, it just gives us billions of devices that can be connected. And it also gives us driverless vehicles. So that, you don't even have, like, it'll drive itself. Has anybody been in a driverless car, or like a robo taxi or something like that? I think in Arizona there's a bunch of them. I don't know if there's any here in Pittsburgh, but kind of cool, I think, you know. So, oops. So then we would have, you could have sensors that control the environment, like you have like ideas and devices that controls the environment. Um, you have like security systems, like your HVAC systems can be all automated, and with certain AIs, you can pretty much automate everything. Love it. So we're back to the GIS and the GPS. Don't get these confused, all right? So the geographic information systems, they're built on GPS, your global positioning system, which is just a navigation system. And it uses a bunch of satellites, and it helps you find your way wherever you want to go. I don't know how we lived without GPS, because I am definitely not a good map reader. But it gives you this spatial data, right? Which gives you like where the person is, and so that hopefully you're making informed decisions. So for example, some companies like DoorDash or Uber Eats are using GPS and GIS to hopefully deliver your food. And they're actually using little robots now, which are pretty cool too, to deliver all of your food and kind of get something anywhere. And I know that Amazon is also using GPS and GIS as well to make sure you get your products within the day or two that they say they are. So your GIS are focused, those geographic information systems, they're focused on the capture, the analysis, and the use of like your spatial location. And basically the GIS is rooted in geography, right? And it's trying to integrate and create these visualizations and these maps and to enhance the software to hopefully give businesses real-time access to what's out there and how everything looks. And I think with Google Earth, you can pretty much see like everything on Google Earth, and you can even go down to the street view and see GIS at its best. So a lot of companies are using GIS to include some telecommunication providers, right? So they're going to map out like cell tower placements. Some retailers might use it to see what products and what regions work. Maybe from a marketing perspective, this product would be put in this particular region because of the demographics of that region. So marketing is combined with GIS, and then business leaders like sales maybe, and then possibly even when you're looking at GIS from a vendor perspective, maybe these vendors that are closest to your distribution center is better so that you can get the products when you need them, or the inputs or when you need them. cellular networks and mobile communication. I don't even think people have landlines anymore. At least I don't. Why when you have a cell phone, right? And it's just essentially it's a two-way radio, right? It's a radio transmitter and a receiver, right? So you just use your phone like it's nothing, right? And it gives a signal that's transmitted via radio waves to the cell tower. The call is received, then the nearest tower gives us that information. It's converted back, and then you're calling and you're talking, and hopefully everybody can hear each other and you have fabulous reception. And here is a depiction of like a cell phone communication towers, right? And so depending on where you're at, there's a base and there's antennas and there's towers, and you'll get signals as you're driving along, and hopefully no blank spots. So key terms that are related to cell phone communication that you should have in your notes is the base transceiver station, right? So that's the base station and it's connected to the cell tower. Then you have a mobile switching station here. And that's like where you're kind of going from a mobile telephone switching office. This gives you the transmissions between the cell phone towers and the base receivers. You have an ADC, analog digital converter, right? And this is what makes your phone, your actual call possible. And then you have a digital single processor, which is a small computer that's in your phone that basically sounds and it gives you all of the, that it's ringing. So make sure you have these in your concept notebook as well. So we talked a little bit about the Internet of Things, and it's basically everything connected to the Internet. It's the objects that are connected to the Internet that talk to each other, whether they're sensibles or wearable technology or smartphones. And there is 30 billion Internet of Things devices across the globe, and over $3 trillion were spent last year on endpoints and services. So it is a huge market out there for the Internet of Things. So now we've moved to 5G connectivity and no longer in 4G. So 5G networks, it can give you a lot more amounts of data. It can give you, you could have autonomous vehicles that can operate. Oops, sorry about that. Efficiently. You can have a bunch of connected devices that improve what businesses and individuals are doing. So it just seems like data is getting bigger, better, faster. And then the benefits of 5G is obviously that faster connectivity, faster data speeds, hopefully allows for more high demand devices to be connected. So you have a greater capacity and lower latency, right? The lag time. Nobody likes to wait when you see that little, spooling icon. That just drives me crazy, right? You want it to be quick and fast. So hopefully 5G gives us all of that. Now let's shift our gears to the cloud and cloud-based applications. So again, for your exam, you cannot have cloud-based applications. You have to actually have the desktop, like a PDF reader in your computer, right? So we don't want that. But cloud computing is what most businesses are doing now. And they're also using cloud applications. So everything can be done through the internet. And we see that 70% of global businesses and 93% of small businesses back up some portion of their data through a cloud provider. And in the US, we have 96% of organizations that are using the cloud. I think this became also quite extensive during COVID. We saw that so many companies had to pivot and go to the cloud and make sure that everything was available from remote locations. So why do organizations prefer the cloud? Well, first and foremost, it's money, right? We have cost savings, hopefully, and then you don't have to have like a whole IT infrastructure. You don't have to have hard disk space. You could hopefully easily collaborate, right? You could have multiple users. They can share the same file. They can all work on the same file. Disaster recovery, you could back up and hopefully make that recovery easier if you did lose data. And the flexibility, right? You can access so many different types of data files and programs, and you could do it from pretty much any device anywhere in the world. So it's really making businesses far more global. So cloud computing, right, is a model where you're either processing, storing, you either have the software, the applications, a whole bunch of services, and mainly through the internet. So you don't need to have those data files. You don't need to have something stored on a device. I know Apple iCloud. I know several of you guys use Google Drive. We have Microsoft 365 and we have OneDrive available at IUP. You could also have Google and Amazon Web Services. A lot of universities use Amazon Web Services, and I think there was a time once when it was down and everything was at a standstill because so many people are using Google and Amazon Web Services. SAP and Oracle also provide like accounting software directly, or ERP or SEM and CRM software all on the cloud as well. And here you see a depiction of cloud computing. So you see all of the devices, like your phones, your laptops, your servers, and then all of the application services that are provided, the infrastructure services, and then the platform services as well. So, benefits of cloud computing. Everything is self-serve, right? We all want to do things for ourselves. You can pretty much do anything by yourself. It also has a broad network access. So you have capabilities that are available over the network. You can get those through some thick client platforms. You can connect any type of device. Like I mentioned before, you have resource pooling, so you can do all of your computing resources. They can be pooled together, and then multiple people can use multiple different aspects of the network. Hopefully, you have rapid elasticity, right? That you are able to release to a scale outward and inward, and you can kind of grow with the demand. And then you have measured service, which the cloud systems automatically control and optimize the resources. So you're leveraging that capability and you're hopefully providing the services with no interruptions. Now, nothing is ever without some disadvantages. You could have downtime. Like I mentioned, Amazon Web Services went down one time, and that was scary, right? You might have some security issues that might, you could store data files and use the cloud computing, but there could be a level of risk if they're hacked, which we see more and more of. You have limited control when you use a cloud infrastructure, right? Because that's managed and owned by that cloud service provider. So you really don't have any control over that. And you have to abide to the vendor agreement from the cloud service provider. And sometimes that can be a little bit challenging for organizations, especially running it through legal. So we have a cloud deployment model, and basically that's just a configuration of a specific cloud environment. So you'll look at like your storage capacity, how quickly you need accessibility, the computing requirements, the network requirements. You identify all of those, and then you create your deployment model. And so there are 4 cloud deployment models that you need to be aware of, and this is identified by the National Institute of Standards and Technology. So make a note of that. So the NIST, the National Institute of Standards and Technology, has 4 different models. You can have a private model, which is just basically one organization and a bunch of business units, or you can have a community cloud, which is basically for a specific community within the organization. Or you could have a public cloud, which is owned and managed by a business or an academic or government. Or you could have a hybrid cloud, which is a combination of a couple of them. And that's what I see more commonly. So hybrid, you might have a community and a public cloud, or a community and a private cloud. Or you could have all of them combined because of the different business units that are using it. So we have, again, different service providers. Amazon Web Services is one of the most broad ones. We have Google Cloud, we have Camerata, and we have Salesforce. I would say this one is probably the most that I've seen used for CRMs, right? Customer relationship managers. And AWS, I mean, it could be anything from an LMS or a whole ERP. They host quite a bit of things. Then we have a content delivery network. So this is a geographically distributed network, which usually has a bunch of servers, and they work together to deliver your web pages or web content to users. And so we at IUP have a content delivery network for our website, and it usually will give you less load time, and it hopefully protects the the website from any surges or any traffic. So a content delivery network. And the process to that is basically pretty easy, right? You just have visitors that are coming to your website that go, and then the content goes to the website server. They get a storage location where it's archived, and then they know like the points of presence here, which is where you are, located. So your points of presence. And that could also be caching servers that it's going to assist you to get that website to the visitors and hopefully the operational proximity. So if you're here in Pittsburgh, then hopefully if you're buying something, it'll come from that location. Then we have web services, right? And that's a bunch of technologies that we can exchange information. And we're trying to do that through like a standardized web communication protocols and standardized web communication languages as well. And web services, you can use that to get some apps maybe for different things. You might also have XML, right, which is existential markup language. Note of that, your XML is existential markup language. And basically, that's a World Wide Web consortium. And this is a language that is designed for both human and machine readable text. So we have XBRL. So in finance, we have XBRL, which is existential business reporting language, which lets us read the financial statements as humans. And then lets the computers read it too with metadata tags so that we can do the analysis on it. We talked about software as a service, which is just a cloud-based service that usually is given by vendors. And it lets you use software applications like a web browser or like an internet connection. And it could be simple access to like Microsoft Office applications. Google Apps is another example of a SaaS. So make a note of that because you might see that on your test. I love Google Apps. That's how I run my website. So again, advantages and disadvantages. The advantage is that you can have frequent updates that occur to the applications. There's very little upfront costs to use them. The major disadvantages is you need the internet connection to get to all of the applications. Oops. Then we have a platform as a service. So we have a PaaS, and this is also a cloud-based model, and it's a cloud service provider, but now you get hardware and software tools that you need. And so you'll host the hardware and software then you need to develop your own infrastructure. And so we have software development kits that is part of the platform as a service. Then we have infrastructure as a service. And so now this is like an instant computing infrastructure. So you might have processing of data, you might have data storage, you could have like other computing resources that the cloud vendor would give you. And it's basically running your information system, whether that is a management information system, accounting information system, whatever it is, it's basically allowing you to have computing service providers. Microsoft Azure is probably one of the biggest ones now out there. And a lot of IT areas are using that. Then you might have a serverless computing, which is basically you just have a cloud service provider and they offer back-end services. So that's what Amazon Web Services, they give you a lot of fully managed like serverless services. And they have also AWS Lambda, which is the computing part of it. And then they have Amazon Simple Storage Services, S3, and that's where you can put everything in there. But there's no SQL database services as part of that. Then you have a cloud service security, right? This is also cloud security, and this is important, right? We don't want to, you want to make sure that all of your cloud-based systems, software, applications, everything is secure because we all know that, they get hacked. So when you are looking into cloud security, these are some of the questions that you should consider. And this is probably one area that I think in businesses we should spend a lot more time on, right? We need to make sure that we know what our disaster plans are. Are we in compliance with all of the regulations? We should do external security audits. We should have, sorry about that. We should have some specific security certificates. Maybe we want to keep data separate. We want to think about that. And encryption, right? Make sure we have the best encryption and try to secure all of the data. This is something that I think should be reviewed annually from a business perspective because it's just your data is more and more valuable. And obviously you want to protect your data at all costs, but you also want to make sure that you're in regulatory compliance. You don't want any fines or fees. You got to make sure that you're protecting the customer's privacy, especially to be able to be in compliance. And you want maybe authentication rules for different users and devices, right? So that way you only have access to what you need when you need it. A VPN, a virtual private network. This gives us a secure connection between two computers. A lot of organizations use this. Most businesses do. That way you have a secure connection and you access the data. And then when you download the data, you pretty much, everything is pretty secure. So we do have this at IUP as well. And anytime I want to download any reports, I have to make sure I go through the VPN to get all of the data that I need. Blockchain and cryptocurrencies. This is becoming better and better. So blockchain is a computer code that creates and concatenated, but like a link between transactions. And this is really changing the way that businesses handle transactions. So we have like contracts that can be done through blockchains. A lot of monetary transactions are done through blockchains, and that comes into an integrated ledger. We can do audits through blockchain. We have supply chain management that can be done through blockchain and quality assurance, right? We want to trace any mistakes and error, and we can trace that back to the point of origin. So blockchain and integrated ledgers are really changing the way that business transactions are done and hopefully far more securely. And then what the name refers to is how the data is stored, right? So it's just transactions that the transaction data is put in blocks. They form a chain, and then the total number of the transactions is what the blockchain is. So it records and confirms like the time, the sequence of transactions when they're recorded, and it puts everything is controlled by rules and guidelines that the member of the blockchain or the network create. So it's usually, and a lot of businesses are transmitting funds and transactions through blockchain now. And each block has a hash, which is a digital fingerprint or unique identifier, which is what makes it a little bit more secure. And then it keeps the previous hash, it links the blocks together to prevent anything from being changed or manipulated. And that's what makes it so secure. So each block is strengthened with each verification of the block, and then it just keeps getting, the integrity of the blockchain keeps getting better and better. I love blockchain. So basically, to add a new block, you just need to have the transaction, right? You get the transaction gets verified, it gets stored, and then once you get that hash, that gives you that extra security. So what do? So first, the transaction has to take place. So, if you want to buy something, then you verify. So the computers in the network go through the details and make sure everything is, as it should be, the date, the time, the amount, the buyer, the seller. The transaction is then stored. And once you get this hash, that's the block that can be added to the blockchain. And that is the unique identifying code. So make a note of that. A hash is a unique identifying code. Then we have cryptocurrencies, which are digital currencies that exist between computers and they're transferred between people. There is no such intermediary as a bank or a financial transaction. They're recorded in a digital public ledger that is called the blockchain. And so Bitcoin is probably the most popular, but then we have these others as well. And I think I put that in your lesson also. And so this is how cryptocurrency gets started, right? We have a blockchain that uses the cryptocurrency transactions. Then we have a transaction from peer to peer. We get a network node to collaborate and validate the transactions. Then we have a series of transactions that creates the blockchain. And then anybody that's participating can approve or issue the cryptocurrency. And then we have the steps to that, right? You need to decide on a consensus mechanism, whatever blockchain platform we're using, the nodes, then we create that architecture for the blockchain. We do an API integration, and then we have the interface, and hopefully everything is compliant and we're good. So the different cryptocurrencies, we said Bitcoin, and then we have ETH and BCH, and all of them have some type, they're just like the top three. And I think in Everly, when you look at the ticker symbols, you'll also see the Bitcoin symbols as well. So it's kind of cool. And now we move on to our last phase, which is our collaboration software. And basically what this software is designed to do is hopefully enhance your productivity, your efficiency, your effectiveness across your teams or your groups. It gives you like a dedicated workspace. It might have data and workflows like SharePoint. You can build workflows so that way it automatically sends it to the next person to approve. And you will have all of this to hopefully make the company run smoother. And this collaboration software is, hopefully for better communication, to manage your projects, hopefully improve engagement across the organization. And one of the main ones is streamlining workflows. So you might have a smart sheet. Excel now has a smart sheet that you can put everything in that, and and it's web-based. And then you have Slack, and Trello is one that I use constantly. This is just like a visual representation of what everybody's working on. So I would say Smartsheet and Trello are the ones that I use the most, but I know a lot of organizations that use Slack as well. And we are all done. Oops. We are all done with this today. Look at that. You made it. Let me stop sharing a second here. Any questions before we go?